Happy Friday. I have today off because I'm traveling to see a friend and I'm very excited, but the teacher and me can't leave you without this video because we didn't have class this morning. And I just can't do it. So we have our mid-unit test with some of these new ideas. Those of you who come to class, I truly appreciate your time and your thinking. Those of you who watch these videos, I also appreciate you. That's part of our online school. We're asynchronous. We may not be in the same room right now together, but I am still here for you, here for your support and your feedback. And so as soon as you let me know, hey, I like those videos, it's in me, it's in my brain, and I want to do them for you. I enjoy them, and I'm here to help you. So thank you for the thinking. I remember learning and being like, this is frustrating, right? Whenever you're independent or when you don't have help, you're like, I just need some help understanding. So that's the other reason this video is coming out, because I just couldn't. I've got time. Let's get it in, right? View and copy. Remember, you have 3 attempts on all of the mid-unit tests or unit tests. So never be afraid to just try the first one. I know that sounds silly, but sometimes when we try the math and we think, oh, that made sense, and then that didn't make sense, but we have the opportunity to go back and review, think about the ideas, and then try them again, we actually learn more. Remember, that's my goal. So you learn these fun and interesting ideas. And if you forget them, that's all right. You understand the basics of how they work, what's going on, and you can relearn them or remember them with a little bit of review, which is as you've watched with me. Okay. A quiz consists of 3 true or false questions and 2 multiple choice questions. The multiple choice questions have 3 options each. How many ways can a student complete the quiz? Okay, you might have this exact question and think, oh, there's my answer. Let's do it, right? You might not have this variation and think, oh man. 3 true or false questions, 2 multiple choice questions. So we have 1, 2, 3, 4, 5, right? How many options for the true or false? Just 2, T or F. How many options for the multiple choice? 3. So we should be able to get to 72 if we do fundamental principle of counting. 2 times 2 times 2 times 3 times 3. 2 times 2 is 4, times 2 is 8, times 3 is 24. Here I got to write it down so I don't forget. 12, carry the 1, 72. 3 times 4 is 12, carry the 1 if you want to do it like that, or you could split it up. This is very important. The distributive property, 3 times 20 is 60. 3 times 4, 24, right, is 12. 60 plus 12, 72. It's called compression when you start to do that mental math and you start to compress the ideas of the way that the numbers work. It's important. Try it. Still use that calculator, but remember to always think about it. All right, that was question 1, variation 1. Let's go. Question 2, variation 2. A secret code consists of 3 digits followed by 2 letters followed by one of the following symbols. Ooh, hey, they do use this for security measures. They do. Number theory and even that little code. Oh, I don't have anything on here. All right, if you ever buy anything and you see the UPC and the little like the scanner and the numbers, well, math is involved. So, and kind of the math you're starting to learn. 3 digits, 2 letters, one of the following symbols, digits and letters cannot repeat. How many secret codes are possible? Here we go. 3 digits, 1, 2, 3. Well, we have 9, 10. My gosh, see, I told you I always forget. If you watch the other video, I'll confuse myself. The digits include 0. So there's 10 possible altogether. Then, since they cannot repeat, so we can't ever have the same, we have 10, 9, 8. That's how many options for the first 3 digits. We have to keep going, followed by 2 letters. So 26 and then 25, because we have 26 letters, but we can't repeat a letter, so we take out that option. So now we have 26 and 25. Let's keep going, followed by one of the following symbols. 1, 2, 3. Only 3 options. So if I did this correctly, and if is a real thing in math, I'm going kind of fast. So fast. Super speed, right? 9 times 10 times 9 times 8 times 26 times 25 times 3. We should get 1,404,000. Woo! 1,404,000. Cool. Same process and logic. If I went too fast, pause it. Got it? Pause it. Question 3, variation 3. How many distinct arrangements can you make using the letters banana? Hey, this is actually on your book. We're going to go show you something because I'm all for this. I don't have any desire to, where is it? There it is. So many. I know. I need to organize my bookmarks. My very first content partner teacher showed me how she organized her bookmarks, and it was beautiful. Absolutely beautiful. I just didn't. It just is what it is. Okay, here's some permutations. And if you're working through your lessons in your book, look at this. First, find the number of possible distinct arrangements using the letters in the words. So 23. Number 23 is banana for the problem set for permutations. So we're going to go to resources. We're going to hit this drop down arrow. We're going to scroll down. Shush. Boop. Okay, now we can come back. We can go back to our book. I highly recommend having this book open. Using books, using instruction manuals is a very important part of this life. We do it all the time. I was actually thinking how fun it would be to make a video if we asked people to learn and do things, but then took away all their notes, right? A recipe, if you've never done it, building something like, here you go, study the instructions because we're going to take them away. And now you have to build this bed from IKEA, right? How funny would it be? It would be very funny. So yeah, use it. Permutations, banana. Number 23. Okay, so they don't actually say it. Look, 6 letters with the letter A occurring 3 times, with the letter N occurring 2 times. So the formula is 6 factorial. Let me zoom in. 6 factorial over 3 factorial and 2 factorial. Going back to our book, right here, permutations with like objects. N choose N is just the total amount you have factorial. That's what it is. The P and the Q factorial is whatever you have that's repeated. You put how many times it's repeated and then factorial to get the right count. I'm not saying this makes sense to me. Visually, and when I try to arrange it in my mind, I can't see where this division keeps it accurate, but that doesn't matter. At this point, there's points and times where like, I don't understand why I have to put this washer with this bolt. That doesn't make any sense to me. Why can't I just screw it down? That doesn't mean I'm not going to put the washer, then the bolt, and screw it on there, okay? I'm going to follow the instructions even if I don't understand why it's there. So at this point, I don't really know why. I'm not 100% convinced, but that's one of the reasons I love this subject. Still that debate in my mind. But I know how to do it. So the answer should be 120 divided by 2 with 60 distinct arrangements. So the math is right here. I didn't actually do the math, but it's right here. So try to follow along. Remember, factorial, you just do 6 times 5 times 4 times 3 times 2 times 1. 3 factorial is just 3 times 2 times 1. 2 factorial is just 2 times 1. But the neat thing is, see how they split it up? You can still cancel if you have one in the numerator, one in the denominator. They cancel because they will become 1. So that's what we do when we cancel. It's actually the property of division. Anything divided by itself is 1. Because division is asking how many groups of the thing we're dividing is in the thing that's being divided. And 1, if they're exactly the same, there's 1. Okay, keep thinking, keep going. Let's go. That was question 3. Oh, let's prove it. 60. Question 4. Question 1. How many ways can a dance instructor send 4 of her 11 students to a summer dance program? Let's go to Desmos at this point. Let's see what's going on. Oh, no, I want Desmos Scientific. Also discovered GeoGebra is quite impressive. Let's go to functions, NPR. We've got main, we've got 4, 11. This might not be right, actually. Yep, oops. It was not right. What did I do wrong? 4, 11, 4. Remember how many you have versus how many you're sending. Let's do this function because we're moving on into combinations, which is different. You didn't have a quiz per se, but you had a lesson, friends. You had a lesson. Everybody, let's see what the difference is. 330. So that makes more sense, right? Because at this point, the 4 girls are going to be the same, but it's not in order. So it's a combination, right? What 4 girls can go. But let's go see. It's either And here's why it's important to understand versus just using a calculator. You either have a combination or a permutation. One of them order matters, one of them doesn't. Aha! So look how the answers are both there. Do you see how they're both there? The reason this one's a combination, why is it a combination and not a permutation? Well, because they're all four going to go, but they're not going in any certain order. So it's just this is the group, right? The order doesn't matter. This is it. So it doesn't matter if Jaina and Eloise and Bonnie Ann and Sarah Lee all go together. I don't know. I went country, but they're all going to go. That group is going to go, but there's no order. I don't know if that makes sense, but if it doesn't, you come back here, you zoom out, you work through your online lesson, you download that student guide, you think about these definitions, contrasting permutations and combinations. This is where you have to do your brain work. The calculator is helpful, but it won't do the thinking for you. None of the tools, nothing in our world will do the thinking for you, even this fancy AI that is coming out. There you go. Read it. You got this. Okay. Question 5. Question 1. There are 5 keys on a keychain. One of the keys starts a car. A key is randomly chosen. Okay, so now we have a different thing, right? Now we have this idea of basic probability. Basic probabilities. We're getting into this very important concept that does determine a lot of things in our world. Well, no, it doesn't really determine. It explains. It describes things in our world. It doesn't determine it. That's the key idea. Just because I know there's this dice, right? There's 6 options. It doesn't mean in 6 rolls I'm going to get 1, 2, 3, 4, 5, 6. But it lets me know what the chances that I'll get that. Okay, so here we go. You need to think about the this is just 1, 2, 3, 4, 5, 6 on one die. They're each one time. When I roll it, there's 6 options. So the odds that I'm going to roll a 6 is 1 out of 6. The odds that I'm going to roll the probability, that I'm going to roll a 1 is 1 out of 6. Total number of favorable outcomes, total number of outcomes. So let's go see if that works. Let's just use this definition, see if we can make it. There's 5 keys on a keychain. One of the keys, a key is chosen randomly. Okay, 1 key is chosen. There's only 1 key that starts the car. So we have 5 keys and we're going to choose 1. That's 1 out of 5. So I don't know if they're asking this as a percentage. If they are, you do 1 divided by 5 or 1/5, convert it to hundredths, however you want to think about it, 20%. But it should be 1 out of 5 because that's how they're going to begin talking to you. Then it'll change to decimals. Nope, all right, never mind. 20%. No matter what, though, you need that fluid number sense, that wonderful, beautiful, fluid number sense that will help you in this life. This should make sense. If it doesn't, try again. Google basic probability, crash course probability. I love them. Okay, here we go. Question 6, variation 1. A track coach made a 2-way table to show his runners' gender and running category. Okay, now we're pulling in some prior knowledge way back in unit 1. But all right, let's just see what they want us to do. To the nearest hundredth, what is the probability that a randomly chosen long-distance runner is male? Okay, at this point, you need to be able to read this table. We have male, we have female, and then we have the different categories. So we are looking at the track coach made a 2-way table showing, okay, a randomly chosen runner. So don't think that they are choosing just from the long distance, okay, is male. But now we need to do a little bit of math. So I'm going to use my calculator. This is why when I made 2-way tables, it was a lot nicer. We were required to make a final column for the totals. So there's 28 here, there's 25 here, like male and female. There's 14 here. Yeah, not so popular. Long distance. Blech. Just kidding. If you're a long distance runner, that's great. Now all together, 28 randomly chosen. So randomly chosen. Okay, so plus 28 plus 25. I'm just making sure I'm rereading how they're setting this up. Ooh, and I could get it wrong, but that's the exciting part about math. Truly, truly, truly. Okay, so I only need that. This is the total number of all of the runners, right? All of the sprinters, there's 28. All of the middle distance, there's 25. All of the long distance, there's 14, if I added this correctly. So altogether, there's 67. Okay. Now, we want to know what the probability that a randomly chosen long distance runner is male. Well, number of favorable outcomes, long distance and male. That's the point. Male and long distance. So 9 out of 67. That is the probability for our randomly chosen person. Oh, that we picked that. This is how gambling has a lot of it. So to the nearest hundredth, right? So when I type this in my calculator, I get a decimal 0.13432 tenths, hundredths, thousandths. It's a 4, so it should be 13%, 0.13. I don't know how they want you to write it, so let's go look. But I know what I'm looking for. What is the probability that a randomly chosen long distance runner is male? I read it wrong. See, that doesn't make sense. Okay, well, hey, that's all right. My answer's not on there. So what did I do wrong? Look, even if you didn't see this highlighted, they're choosing from the long distance runners. I thought they were choosing a runner, like from the whole group. But that's all right. Look, they were nice. My answer's not on there. So here's our long distance runners. How many long distance runners do we have? 14. How many are male? 9. So now if we do 9 divided by 14, we get 0.6425857. Doesn't matter, right? Tenths, hundredths, thousandths. So the nearest hundredths, there it is. But that's why you had heard me keep rereading it. The wonderful thing about math, though, I tried it, my answer wasn't there. I reread it and thought, what next? What next? So good job. I'm glad you saw that. Love it. I've never been shy that I will get everything completely right. Nope. All mathematicians, all math teachers, that when we look like we're getting everything correct, it's because we've done it ahead of time. And I haven't. Oh, we've done 5. Was that 6? Okay, we're on our last question. This is it. Let's do variation 3. You could even think, what is the probability? How many different variations are there of 7 questions with 3 variations each? Then what's the probability that, this is really hard, that I click on every single one of your variations? How that's right? Okay, anyway. The probability of choosing a winning card from a stack of decks is, now they're telling you the probability. Okay, so they want you to do something else. If you've worked through the lesson, they would have given you practice. You would absolutely have practice with all of these concepts, okay? They'll never assess you. I would never assess you if I didn't think you had the prior opportunities to learn it. So please take some time, have some fun. You know what? There's some really there's a movie, but I can't recommend it because it's not like PG, so but there was a group of college students at MIT that did gamble because they understood and this concept. Yeah, very cool. They made lots of money. It works. This works. Okay. All right. And gambling just happens to be one that has to do with odds. So, all right, favorable outcomes. That's great. Ooh. Okay, let's see if A represents the complement of the event. I think this is where they wanted you to go to, though. This is the last lesson. What's the next lesson? Yeah, this is next week. So this is it. This is it. And you can get in here and try to read and practice all sorts of stuff. But the odds are you saw that picture, you saw that question someplace else. Let's go keep going. Let's see what they want. I don't know. I was trying to see. I was trying to guess. What is the probability of choosing a losing card? Okay, so they did tell you right here. It's the complement events. So P rolling a 5, P not rolling a 5, they need to equal 1, right? Because we have the total outcomes. They have to be 100% of the outcomes represented, okay? So the possibility of rolling a 5 is 1/6. So the possibility of not rolling a 5, the complement of the event, then the case that the odds are I'm not going to roll a 5. Like if I'm going to say I'm rolling a 5, ready? Here we go. Watch, I'm going to roll it in this hand so I can show you. Ready? Oh my gosh. No way. No way. Oh, it rolled. Well, now you can't believe me, but it did. I rolled a 5 in my hand. I really did. That's not the expected outcome of the event, saying I'm going to roll a 5 and then rolling a 5. I rolled a 4. So anyway, you just subtract. So 1, everything is going to be, we're going to think about it in terms of 1. Lots of stuff for now is going to be 1, 100%, 1 total. 1 will now represent the whole group. And then all of the different possibilities are going to be less than 1. Okay, that's why when somebody's like, I'm giving 110%, you can be like, mathematically, you are lying. You are lying. So let's go do that over here. 100%. Oops. 100 minus 4.3 should be 95.7. So 95.7%, let's see, hold on, let me read it. Choosing a winning card from a stack of decks is that. So the probability of choosing a losing card is 100% minus that, because the rest of the cards are the losing cards. That's what's happening here. Let's see. So 95, let me write it on the board. Well, no. Yes. No. 95.7. There you go. The reason I didn't want to write it wasn't because I didn't want to write it in case I was wrong. It's because sometimes it affects my ability to scroll. It won't let me scroll up or scroll down. Okay, that was a very quick overview from some pretty awesome and powerful concepts in probability and statistics. So pause it, take your time, try to get practice in, have some fun with this, challenge your family, your friends, right? Text somebody, what are the odds? And then show them. And then I can, anyway, if you're interested, I hope to pique your interest. This has a lot of great career fields. This topic, this subject, you can do this as a career and make decent money. It was, anyway, just not, it's not always about the money, but it's also incredibly interesting and satisfying once you get the hang of it. Even if you make mistakes. Look, I made a mistake for you guys on this test, on a test. But my answer wasn't there, so I'm not just going to click 21 because that doesn't make any sense, right? I'm not just going to click when, if there was like a 14 or 12, I might, right? I might. But no matter what, my answer was not there. I'm going to start over. So, okay. All right. Thanks for watching, and I hope you guys have a great weekend. There's no school on Monday, and the due date, if this due date doesn't mark off, I'll remove it. I just want to make sure you guys see it on your plan. Okay.